Hi everybody, so tonight we're going to review for your homework, chapter 7 homework. So I'm going to pick and choose the ones that I think are important. Just pay attention to what I'm doing and the exercises I'm doing, and then you will review with that, and hopefully those are going to help you do your homework, okay? So let's start. It says here the p-value for hypothesis test is shown. P-value, use the p-value to decide whether to reject the null or fail to reject the null. We all know. And they gave you different level of significance. We already know that for you to reject the null or not to reject the null, if the p-value is less or equal to alpha, then we reject the null. If the p-value is greater than alpha, we fail to reject the null hypothesis. That's how it works. So p-value 0.07. So 0.0743. This guy is going to be greater than 0.01. This is what we have. So we're going to fail to reject the null because the p-value is greater. So we're going to fail to reject. Over here, 0.0743. And this is still greater than 0.05. And we're still going to fail to reject the null, right? Because the p-value is greater than. And finally, 0.0743, we're going to compare it to 0.10. So it's less or equal to 0.10. So we're going to reject the null because it's less than. All right, so we're going to reject the null because the p-value is less than. So there goes your answers. So remember how you decide your decision rule using the p-value. Now moving on to number 2, match each p-value with the graph that displays its area without performing any calculation. Explain your reasoning. So there goes a p-value and another p-value. So explain your reasoning. Match each p-value with the graph that displays its area. Now I see. Now remember how we used to do this, right? So if this z is negative 0.97, so the p-value is going to be a probability that z is less or equal to negative 0.97. This area right here. So it's the same as normal CDF, negative infinity or negative big number, right? Comma negative 0.97. Or you're going to put normal CDF, negative 10,000, negative 0.97. So I'm going to put that in the calculator, second function DISTR. Normal CDF, a big number, negative 0.97. So we get here, this p-value is 0.1660. And over here, we'll do the same thing. P-value is going to be the probability that z is less or equal to negative 2.27. So normal CDF, negative 10,000, negative 2.27. What does that give me? Negative 2.27. So this guy gives me 0.0116. So let's go ahead and try to figure out. So graph A, okay, graph A displays the area. There you go. You see that? And graph B displays the area. Here we go. Because p-value is, let's see, is equal to the shaded area. So I'm going to take a picture of this guy so you guys can see. So this is the calculation for each p-value. All right. So you guys have access to this. Yeah. Here we go. See? Let's move on. It says find the p-value for the indicated hypothesis test given the test statistics Z, the level of significance. All right, so they say a right tail test. It has to be a right tail. So we're talking about this. The Z statistic is 1.20 and alpha is 0.08. All right, so your p-value is going to be probability that z is not left but to the right. Okay, it's to the right, 1.20. So it's normal CDF. Okay, so you start at 1.20, you go to a big number. Okay, you put that in the calculator, normal CDF. Okay, 1.20, you go to a big number. So this p-value gives me 0.115. 07, something like that. Round to 4 decimal places. So 4 gets me to 0.1151. Okay, so you're going to compare this to alpha. So 0.1151 is greater than alpha. So we're going to fail to reject the null. Okay, fail to reject. So let me give you how you plug in the calculator. Okay, there we go. So remember, you can have area to the right if it's a right tail test, area to the left if it's a left tail test. Now it says use the calculator displaced to the right to make a decision to reject or fail to reject the null. Alpha equals 0.01. Okay, let's look at it real quick. So my mu 0 is at 60. There goes your z statistic. There goes your p-value. Look at the p-value. The p-value is 0.20590, which is greater than alpha equals 0.01. So we are going to what? Fail to reject the null because the p-value is big. Since p-value is greater than alpha, we fail to reject. That's that. Now it says find the critical values and rejection region z-test, two-tail test. So if it's two-tail, you know you're going to have two rejection region. I know I'm talking to everybody here. Your alpha, you're going to split it in half. Are we all on the same page? So 0.005 divided by 2. So each area here is 0.0025, 0.0025. This is how it is. So these are your critical values. Excuse my language. It's not z-stat, but critical values. So negative zc, positive zc. Okay? So your rejection regions are two regions. So it's this guy. This is it. The question is, what is this guy? You do inverse norm. We already know. Area to the left, 0.0025. Okay? So you do that. Inverse norm, 0.0025. So this guy is negative 2.807. This is 2.807. All right? It says round to 2 decimal places as needed. So your regions are going to be this guy here. Z is less than and Z is greater than. Okay? So negative 2.81, positive 2.81. Okay? So this is how it works. Critical values in plus or minus, so negative 2.81, comma 2.81. Right, let me take a picture of that. Remember, if it's a two-tail test, you have to split the alpha in half. You have to split the alpha in half. You have to split the alpha in half if it's a two-tail test. You have to split the alpha in half. That's it. Okay, let's look at doing a test. So test the claim about the population mean. Yeah, there goes the claim, mu different than. So it's a two-tail test. And this is the alternative, different than. They give you alpha, they give you sigma, they give you the population standard deviation. I need everybody to notice that. The sample statistics are right here. Okay, so mu different than, if HA is mu different than 5,000, then HO is going to be mu equal to 5,000. So let's find that really quickly. This is it. C. Does that make sense? So make sure you have that, right? That's your 6. Okay, and now calculate the standardized test statistic. So this is a z-test. How do I know? I have any population because it didn't tell me whether the population was normal. I have n, which is 33, which is greater, right? Greater than 30. So it's a large sample. And on top of that, I have sigma, which is known. So I know this has to be a z-test. Okay? So if that's the case, I'm just going to go to my calculator, go to stat test, z-test, and I'm going to enter that information in there, right? I'm going to quickly type that in and just share it with you guys as a picture. But it's a matter of knowing how to use your technology and knowing how to recognize which step test to use and which one not to use. All right, so this is how we set up. Okay, this is how we set up. And now I'm gonna go ahead and I'm gonna find everything I need to find. So calculate, it gives me everything I need. Let me take a picture of that. Okay, it gives me the z-stat, it gives me the p-value, etc. So here we go. I need everybody to notice something. Right here, let me crop some more. Okay, so notice your p-value. This is scientific notation. This guy means 3.32 times 10 to the negative 8, which is 0.0008, in fact, 8 zeros. 0.000000, 1, 2, 3, 4, 5, 6, 7. And then you have a 0 and then a 3 and a 3 and a 2. So this is what so it's close to 0. Your p-value is close to 0. Your z-stat is 5.52 whatever, round to 2 decimal places. So that's going to be 5.52. Your critical values. Now this is a two-tailed test, isn't it? Alpha is 0.02. So this is what we have. A two-tailed test, right? Alpha equal to 0.02. So this is going to be alpha over 2. Alpha over 2. So 0.02 divided by 2, that's 0.01. Let me pick another color here. So this is going to be 0.01 and 0.01. So this guy is inverse norm, 0.01. So second function, DISTR, 0.01. So this is negative 2.33. This is 2.33. So round to 2 decimal places. So plus or minus, yes, 2.33 is what you should have. Okay. Now, you know what your standardized test statistic is, 5.52. Okay, we know what that is. So when you look at the graph, this 2.23 is going to be here and here, but the 5.52 is going to be somewhere here. So 5.52, which is the z-stat, is going to be in the critical region. Does that make sense? So it's going to be in the critical region. We're going to reject the null. We're going to reject the null at 2% significance level. There is enough evidence to support the claim. We reject the null. All right. Remember, your claim was in the alternative. The claim is HA. So the claim was in the alternative. So if we are rejecting the null, we are supporting the claim, because the claim was what? Mu different than 5,000, which is the alternative. I hope that makes sense. All right. So let me look at 7. 7 is using the p-value method. 7 is using the p-value method, which is pretty simple. They gave you n equal to 76. Mean score, x bar is 276. Population standard deviation, sigma is 32. Alpha is 0.12. Say states this test result prompts a state school administrator to declare that there goes the claim. The mean score for the state's 8th graders on this exam is more than 270. So HA mu is more than 270. So the null is going to be mu is less or equal to 270. 270, yes. So this is my claim. The claim is in the alternative. All right. So let's find that really quickly. So this is it. It's A. Okay, it's A. Now, what's the Z-stat? You're going to go to Z-stat. You're going to go to stat test. I'm not going to do it for you guys. Stat test, Z-stat. Oh, shoot. Stat test. And then you're going to put the information in. Stat test, Z-test. You're going to put the information in. So mu 0 is 270. Sigma is what, 32. Sigma is what, 32, yes. X bar is 276. N is 76. And then this is more than test. Let's take a picture of that really quickly. Okay, and then this is what we have. And then we calculate. So our Z round to 2 decimal places is 1.63. Our p-value is 0.05 to 3 decimal places 1. Now the p-value compared to is less than 0.12 alpha. So we're going to reject the null. So at the 12% there is enough evidence. There is to support the claim. Enough evidence to support the claim that, Sarah, remember where the claim was in the alternative. So if we reject the null, we are supporting the claim. All right. So this is part 1. In the part 2, I'm continuing the exercise with you guys.